Hello everybody, welcome to my channel. This is my second video. So in this video, I will discuss how to find out the sum of numbers uh, 1 to n, or a series of numbers 1 to n, or square of numbers 1 square plus 2 square to n square, or cube of numbers 1 to cube plus 2 cube plus n cube. So I have already discussed and derived the formula for these in the earlier video, but today we will derive to show a method by which you can derive the formula in a more generic way. So this is the equation. This is the problem statement. We have to find out the sum of these series 1 plus 2 plus 3 up to n, or 1 square plus 2 square plus 3 square up to n square, 1 cube plus 2 cube plus up to n cube. Now, while finding out the sum of these series, we have shown different methods for different series. Like we have a different method, showed a different method to find out the sum of series 1 plus 2 plus 3 plus 4 plus up to n. A different method plus 1 square plus 2 square plus 3 square up to n square, and a different method plus 1 cube plus 2 cube plus n cube. But today I am going to show a generic method which you can use for all the series like this, whatever the series that they are like this. So let me show you how to do that. So to do that, I will show you for one of the series, which is the cube of the series. You can deduce the rest of the series in my one of my subsequent videos. I will discuss the other two, but today I will mostly focus on the series 1 cube plus 2 cube plus 3 cube up to n cube. So to find out the sum of this series, first we have to write how the series will be if we write it in numerical form like this. So 1 plus 2 cube plus 3 cube ultimately will look like 1 plus 8 plus 27 plus 64 plus 125 plus 216 plus 343 plus up to n cube. So this is level 1. So in after we write this, we find out the difference of two subsequent numbers in the series. So it becomes 8 minus 1 equal to 7, 27 minus 8 equal to 19, 64 minus 27 equal to 37, 125 minus 64 equal to 61, 216 minus 125 equal to 91, like that. So in the second level, again we are finding the difference between the second level, we are finding the difference between the two consecutive numbers. What we Once we find the difference between these consecutive numbers, we try to find out whether these number difference are constant. We find in the second level it's not constant. So again we take the difference of the differences. So of the consecutive differences. So the how what I mean by that. So it's like we get 19 minus 7, it becomes 12, 37 minus 19 18, 61 minus 37 equal to 24, 91 minus 61 equal to 30, like that. So the now after finding out the differences, we at the third level we want to see whether these are constant, and we see clearly that this is not constant, so we go to another level. So in the next level we find the difference 18 minus 12 equal to 6, 24 minus 18 equal to 6, 30 minus 24 equal to 6, 36 minus 30 equal to 6. So this is constant. So if this is constant, at the fourth level, we find out that if for this series at the fourth level, if we find the difference of the two consecutive numbers and the difference of the differences like that, in the fourth level, we find out it becomes constant. Once we find out that, we confirm that the equation which will represent the sum of this series will be a fourth degree equation of n. What do I mean by that? I mean by that is the equation that will represent the sum of this series will look something like a into n to the power 4 plus b into n cube plus c into n square plus d into n plus e. So it's a equation of fourth degree. So for to find now in this equation we have to find the find the values of a, b, c, d, and e. Then we will find out the formula. So to do that, we have four variables. So we have to find out four equations to solve that. So to that we put n equal to 0, n equal to 1, equal to 2, n equal to 3, n equal to 4 in the equation. So if we put that n equal to 0, we find that the sum of this series will be 0. So and in the right hand becomes 0, and left hand, if we put n equal to 0, we get e. So e equal to 0. Similarly, if we put n equal to 1 on the left hand, it will be 1 cube only. So that is 1. And in the right hand, we get a into 1 over 4 plus b into n 1 cube plus c into 1 square plus d into 1 plus e. That is a plus b plus c plus d plus e. So that is also 1. That becomes equal to 1. Like that, if we put n equal to 2, that is on the right hand we get 1 cube plus 2 cube equal to 9. On the left hand we get 16a plus 8b plus 4bc plus 2d equal to 9. So like that, in equal to 3 we get 81a plus 27b plus 9c plus 3d plus e equal to 36, and in equal to 4 we get 256a plus 64b plus 16c plus 4d plus e equal to 100. We have four equations now for four variables. We've solved that. I will show in one of my subsequent videos how to solve these type of equations, subsequent equation, simultaneous equations uh, easily. But today I am not going into that. Today I directly solved that, and I came out with the solution. So it becomes if we solve all these four equations, we get a equal to 1 by 4, b equal to 1 by 2, c equal to 1 by 4, d equal to 0, e equal to 0. So if so the equation becomes for me 1 by 4 into n to the power 4 plus 1 by 2 n cube plus 1 by 4 n square. So this is the equation for the sum of the series of cube of numbers, I think 1 cube plus 2 cube plus 3 cube plus n cube. So that becomes n square into n plus 1 whole square by 4. So that's how we derive the sum of the cube of numbers. In the similar way, we can derive the sum of the square of numbers or sum of consecutive numbers, like that. It's quite easy now for to derive this type of equation to write this type of for derive this type of formula now. Hopefully you liked my video. I would request all of you to subscribe to my channel, which will motivate me to publish more videos like this. Thank you.